Okay, it is recording now. All right, so um, that's something else. Might not be a bad idea. Um, at the beginning of class every day, somebody remind me to do that and hit record so that I don't forget to do that, so that these sessions will be available to you to go back and look at. So first thing, I still have not received any messages that says you can't hear me. So we will move on and let's talk about the syllabus a little bit. All right. So again, I sent this out as an email. It is also posted on Canvas that you can access this syllabus anytime. And again, I'm not going to go through the whole thing, but I do want to go over a few specific items, and then I'll give you a chance. If you have any questions, we'll address those at that point. So first thing, my name is Andy Walters. If you haven't figured that out yet, by the way, I'm going to be your instructor. I notice looking at the roll, some names I recognize. I've actually seen you face to face before in a previous class, either statics or dynamics. Some I did not recognize, so some new, some familiar people. But my contact information is there. As far as telephone goes, that's my office phone. I am actually in my office now conducting this session. So if it's something you want to talk to me about over the telephone, if you were to call immediately after this session, you probably would catch me in my office. If it's later in the afternoon, I will probably have left already. But you can certainly email me, and if it's a question we can address and answer over email, we'll try to do that. If it's something, because some things are harder to to answer over email, we may set up basically a private 101 WebEx session to try to address or answer any questions that you might have. Okay. I see a message from Nathan. He asked me how I'm doing. I'm doing great so far. I wish everything would go back to normal, but it doesn't look like that's happening anytime soon. But I'm doing great considering circumstances. All right. So first thing I wanted to mention, there are two prerequisites. I checked Friday as a Friday. Everybody that was on the roll satisfied those prereqs, so that shouldn't be an issue. If you're somebody maybe who just joined and are listening to this, I'll mention it for you that you do have to have a C or better in statics or Cal 3 in order to be enrolled in this class. So anyway, be aware of that. Next thing I wanted to mention was the textbook. This is the 10th edition by Hibbler, is the textbook that we are using. It is imperative that you have some version of this textbook as soon as possible. It doesn't matter if it's a hard copy, if it's new, if it's used, if it's rented. If you want to go electronic version, electronic copy, that is perfectly fine as well. I don't care what type of textbook you have, as long as it is the 10th edition, as I'm going to be assigning problems out of that textbook. And if you don't have the 10th edition, then the problems in your edition won't match the problems that I'm assigning. So very important, get the 10th edition of the textbook. One other, while I'm thinking about it, sort of related to that, I mentioned I'll be assigning problems out of that textbook. The list of those problems is posted in Canvas. You can open up the suggested problems for test 1, and you'll see the problems that I picked out of the textbook for each of the sections we're covering. And these are the problems that you need to be working and practicing on. Problems on the test are going to be similar to those problems that I assign out of the textbook. So if you want to do well on the test, you have to practice working problems. This is a problem-solving class, and that's the only way you're going to learn. It's one thing, I normally say, watch me, work problems on the board. Here, you'll be watching me work problems on your computer through WebEx, but it's still the same thing. Watching somebody else work a problem is not the same as you working the problem. And if you want to do well in this course, that doesn't change the fact that we're not face-to-face. You got to work the problems. That's the secret to doing well in this class. And also keep up and don't wait until the day or two before the first test and sit down and try to work through all those problems. As we go over the sections in class, try working those problems, and that's where you'll find out if there's something that you didn't get or didn't understand, and we can address it hopefully and clear that up before the test. All right, so any questions related to the textbook? If you have a question, you can unmute yourself and chime in, or send a text, or not text, a chat message. Any questions related to the textbook? All right, I'm taking silence as everybody's good. No questions about the textbook. All right, so back to a little bit I mentioned a minute ago. Again, this is a synchronous online class. That means it meets every day, 11 to 11:50, just like we were meeting face-to-face, except it will be online. I expect everyone to be here and attend. I see, I think we're one short. I don't know who's missing, but everybody else looks like they're here. Hopefully you will continue to attend the live session every day. As I mentioned a minute ago, I am recording this, and then afterwards I will, hopefully, if all goes well, we'll post a link to this in Canvas so that you were able to go back and review any of these live sessions. But I want to emphasize that I can't 100% guarantee that there will always be a video of each live session. So if you have to miss, I understand some things come up, but as a general rule, try to attend the live session every day at 11. Being live session is we go over something. If you have a question, you can ask the question then, as opposed to if you go back and watch the video, obviously you won't be able to ask the question then. And two, as I said a minute ago, I can't 100% guarantee that there will always be a recorded video of the session. I'm going to do my best. I mentioned a minute ago, I got to remember to click record, so it's possible I forget to do that, especially if somebody doesn't remind me. Or, with technology, things happen. Could be that for whatever reason, I just can't get it to upload. So oh, anyway, sorry, off track. But I'll do my best. I just can't promise, that it will always be there. But anyway, so just want to make sure that was clear. So if you're thinking, well, I don't have to be here at 11, I'll just go back and watch the video later, that may be okay occasionally, but if you're counting on that every day, then you might miss out on something. So try to be in attendance every day. Let's see, moving on. Let me briefly mention we're going to have 3 tests during the semester and then a final exam. The 3 tests will be given at this time from 11 to 11:50. So just like we were meeting in class, if you cannot take the test at 11 to 11:50 on the day it's scheduled, I must have a official approved university excuse to allow you to not get a zero on that. So definitely want to make sure you're available from 11 to 11:50 on test days, because again, you miss the test, it's not excused, you get zero. So the final exam, it will be given the time that is listed there on the syllabus. Is the exam time listed on the university exam schedule. And notice on the university exam schedule, I'm out of, hang on, can't get it to focus. There it goes. It's actually scheduled from 8 to 11, but right now I'm pretty much thinking basically the final exam is just going to be our fourth test. It will not per se be comprehensive. You'll see a lot of stuff we're doing on that fourth test. You're going to have to know how to do some of the earlier stuff to do that. So in a way, it's kind of comprehensive, but essentially it's just going to be our fourth test over the material from the end of test 3 to the end of the semester. So it's not going to be a 3-hour test. So that's why you see the 8 to 9:30 there. At least that's my thinking right now. Homework, I've already mentioned something about that. Let's see. Next, sort of quick discussion about HonorLock and how the tests are going to be administered. And I'll pass along some more information about HonorLock later this week or first of next week. Sometime when it gets a little bit closer to our first test, which should be somewhere around 2 weeks, give or take. As we get closer, I'll let you know for sure. But we are going to be using HonorLock to take the test. And you see there in the syllabus some information about HonorLock. I sent out an email the other day about that they sent me. They had updated their minimum system requirements, at least starting in July anyway, which this course goes on through July. So that's why I sent that out. There's a couple of links there you can go to and get some information. As I said, a little bit later, the end of this week, first of next week, sometime before long, I'll send out some more information and actually give you an opportunity to do like a demo test to make sure you know how to use HonorLock before our first test. You don't want to wait till the day of the first test to make sure that you know how to use HonorLock and your system is compatible. Basically, I'll give you a real quick how the testing will go. Again, I'll give you more specifics closer to test day, but the test will be in Canvas. You'll log into Canvas, open up the test, go through the HonorLock, whatever you got to go through to start the test. HonorLock proctors you taking the test. You'll submit it in Canvas, and then after you've submitted the answers to the questions in Canvas, you will scan your work and email that to me, and that is what I will actually grade. I will go through and grade your work for partial credit. So when you're taking the test, if you submit an answer and it's wrong, and you get 0 points for that problem, don't freak out or worry. Could be you just made one little sign error and that gave you the wrong answer. I am going to grade your work, and that's what your grade will ultimately be based on, is the work that you do and send back to me via email. But it's kind of a strange way to do it, but it makes it easier for HonorLock to actually proctor you doing it this way. That's why it's going to be done this way. Part pause a second, and anybody have any questions related to Honor Lock or how the tests are going to be given at this point? Remember, I'm going to give you some more information later, but if you got a question you want to ask now, again, you can unmute yourself and ask, or type it in the chat, and I'll answer it now if I can. No questions? All right. Not a whole lot else on the syllabus. Just I will point out your first your grade. Essentially, you got 3 tests and final exam, which is basically just 4 tests. They all count the same amount equally. They all count 25% each. So that's what your grade is going to be based on, the average of your 4 tests. All right. The rest of what's on the syllabus there, I think, read over everything as always. And if you have questions now, I can answer your question. I see a question. Hang on just a second. I'll get to that. But if there's any questions, again, related to the syllabus you want to ask right now, you can do so. If not, after you read over everything, ask me tomorrow or the next day. So we have a question, will the final exam replace our lowest test grade? No. That is, the answer is no. That would only apply for one test. If you happen to miss a test, you have an excused absence, and we can't figure out a way for you to make the test up or take the test at a different time or something, then the final exam would count as that one. But only if it's missed due to an excused absence and that we can't figure out a way to make that test up. All right, is that clear, everybody? But in general, the final exam does not replace your lowest test grade. All right, any other questions related to the syllabus, or maybe there's something in general you want to ask about the course that you don't see on the syllabus? Anything? All right, well, I'm assuming then for now there's no other questions related to, just general questions related to the course. Let me check and make sure. Again, I mentioned this a minute ago. I'll remind you, during the semester, if you have a question, related to, like a problem or something we did in class, don't hesitate. Send me an email, and if we can't resolve it by email, we'll schedule a one-on-one WebEx session. I see a question that says, will the practice problems be published soon? I mentioned that a minute ago. They're already should be available in Canvas. If you log into Canvas, you should see a list of the practice problems. And I don't think we're going to get through the first set of problems today, but maybe hopefully after tomorrow, you should be able to start working on the problems from that first section starting tomorrow. But they're available to you in Canvas. All right. Any other questions? All right, then again, we're not going to do a whole lot today, but I want to kind of at least do an introduction to give you an idea of what mechanics and materials is about and what the course is going to involve. And the best way that I can do that is to sort of compare it to statics. Because everybody in here has passed statics, so you know what statics is. So statics, this is the study of rigid bodies that are in equilibrium. so two big things here. Everything you did in statics, you assume the object was rigid. That means it did not deform. Hold on, I've got another question. Okay, so it says in Canvas they're unpublished. I'll go and double check that, but I Friday went in and made sure that everything was published, but I will double check that. I'll write myself a note. Hang on. I took the right on. All right, so I wrote myself a note reminder. I'll go in Canvas and look and make sure. Obviously, maybe somehow it got unclicked, or I don't know. I'll check and see. It was supposed to have been published and available to you, but I'll double check that. Right. All right. So back to statics. There. Everything you did in there, well, we assumed that it did not deform. It didn't change shape. You know, when you had a beam or a frame or a truss or whatever the structure was, when the loads were applied to it, it didn't change shape. But it is in equilibrium, right? Everything in statics was in equilibrium. So that meant all the forces add up to zero, all the moments add up to zero. I know some of you who have had dynamics, because you were in my dynamics class. Some of you may have been in another dynamics class, but those of you who've had dynamics know that's not true in dynamics. That's the big difference between statics and dynamics. Dynamics, things are not in equilibrium. But that's what statics was. Everything was in equilibrium. You assumed it was rigid. So mechanics of materials here, this course is the study of, it's a long word, deformable. I spelled that right. Deformable bodies. But they are still in equilibrium. And so we're still in equilibrium, which is a good thing, especially those of you who've had dynamics knows. Problems that are in equilibrium, much nicer to solve than problems that are not in equilibrium. But the big difference between statics and mechanics of materials, now the objects are not rigid anymore. They can deform, they can change shape. In fact, that's really what this course is about, is determining what effects these loads have on these structures. In a way, and I always tell my class this, the beginning of mechanics of materials, you know, in the university description, statics is engineer mechanics 1, dynamics is engineer mechanics 2, kind of like, you know, their dynamics is the sequel to the statics. But actually, mechanics of materials is much more closely tied to statics than dynamics is. Like, you could call mechanics of materials statics 2. Basically, you go one step further than what you did in statics. In statics, you drew a free body diagram, you applied your equilibrium equations, you solved for these forces, and that was it, forces and moments. But that's where you stopped. Basically, mechanics of materials, you're going to do exactly the same thing. You got to draw a free body diagram, you got to apply equilibrium equations, determine what these forces or moments are. But then in this class, we take it one step further and say, okay, well, what does this force or moment do to the structure? How far does it stretch it? How much does it bend it? Is it going to break? Things like that. So basically, if you understood and did well in statics, typically those students do well in this class, because you're going to see a lot of the mechanics and materials problems. 3/4 of the work is doing statics. The mechanics and materials part, a lot of times, is just plugging in a formula at the end. So if you can do statics, you usually do well. On the flip side, conversely, if you struggled with statics, didn't get a great understanding of those concepts, those are the students who typically struggle with mechanics and materials. I don't want to scare anybody off or, sound, like gloom and doom, but just historically, that's what I've seen. Students who do well in statics do well in this class. Students who didn't do well in statics don't do well in this class. So if you fall into that category that you struggle to get through statics, this is just kind of a heads up warning. You're going to need to go back and work harder than maybe some others to basically learn what you didn't learn in statics if you want to be successful in this class. All right, so that's kind of a general description or idea of what this class is all about. And we actually got a little bit of time to maybe start talking a little bit about internal loads, but I'll pause a second. Again, and anytime if you have questions, don't hesitate. Don't wait for me to ask if you have questions. If you've got a question, unmute yourself and chime in. Or if you prefer the chat, type the message, and hopefully I'll see it. If for some reason I don't see it, then unmute yourself and speak up and let me know you have a question. Okay, don't always wait till I ask if you have a question. Okay, but I'm asking now. Anybody questions about anything? All right. Well, again, we're going to start basically from the beginning, and what I'm going to talk a little bit about today, you will find in your textbook. It's in section 1.2, and a lot of what's in this section, in fact, really and truly, pretty much almost everything that's in this section is things that you should already know. In fact, the section in your book, it says it's equilibrium of a deformable body. And there's a lot of information in there that is literally a review of statics. So I highly encourage you to read through some of this. I got a book over here. Looks like pages 4 through 6. I'm looking at the book right. So if you don't have a book right now, hopefully you get it real soon. Go back in, and especially if it's been a while since you took statics. Again, there's nothing new there. It's all information you should already know, but some of you maybe took statics a year ago or a year and a half ago, and maybe forgot some of that. So go back and review that. One thing that is in this section I want to at least bring up today is something called internal loads. So this internal. Now, this you didn't really deal with a lot in statics. Most of what you did in statics were what we call external loads. But these are forces and moments. And one thing, not so much today, but I don't know, I may draw a picture in a minute, but I know there's a few seconds lag time between the audio and what you see. So I'll try to be aware of that. And when I write or draw something, I'll try to make sure I give time for what you see on your screen to catch up with the audio. So anyway, I just wanted to mention that while I'm thinking about it. These are forces and moments that are internal to the solid body. And basically, they're forces that in moments, they're the loads that hold the object together. We're going to see 4 different types of internal loads. 4 types internal. One we're going to see is what we're going to call an axial force. This is going to be the force that's perpendicular to the cross section. So this will be the direction perpendicular to the cross section. So we're going to call it the axial force. We're going to have a what we call a shear force. This is going to be the force that is parallel or tangent to the cross section. This will be tangent or parallel to the cross section. Right, so those are the 2 different kinds of internal forces we're going to see. We're going to see 2 internal moments. One we're going to call the bending moment. Which I don't think needs any other explanation. You bend something. That's what this moment does. It's the moment that causes the thing to bend. And then there's another moment which we calls it to twist. So you'll have a twisting moment, or sometimes referred to as torsion. Right, so those are the 4 types of internal loads we're going to encounter. 2 forces, 1 force perpendicular to the cross section, 1 parallel or tangent to the cross section. 2 moments. One bends the object, the other one twists it. So what you're going to see as we go through this course, we're going to basically study what effect each of these 4 internal loads, the effects they have on the object. And we'll do this individually. Look at each one. What if you just have an axial force? What if you just have a shear force? What if you're just bending it? What if you're just twisting it? And then toward the end of the course, we will put all these together and see, okay, well, what happens if we have an axial force, a shear force, and a bending moment, all applied at the same time. So that's something to look forward to. That is to come later. But we're going to study each one sort of individually first, and then come back and we'll put them all together. So we'll draw a picture and sort of illustrate the difference between what an external load is versus an internal load. So let's say we have a cantilever beam. It has a fixed support at the left end, and we apply some force F at some angle theta. We'll call this A and this B. So in statics, you might have seen a beam like this. And hopefully one of the things you learned in statics is what type of support reactions that the different supports can provide. That's going to be essential if you want to be successful in this class. So this fixed support, and just to refresh your memory, if the support by itself prevents movement in, say, the horizontal or vertical direction, it's capable of providing a reaction force in that direction. If it prevents rotation, it can provide a reaction moment. So that fixed support, it prevents it from moving and rotating. So we actually get two reaction forces. We'll call them AX and AY. And we also get a reaction moment. Right? That's what that support's capable of providing. Also, if you include weight, that would also be an example of a external force. Now, you're going to find most of the problems we're going to do in this class, the weight would be neglected. But if you were given the weight and you include it, it is considered an external force as well. So all of these, the reaction forces and moments, the weight, the applied load, those are all what we call external loads. And for the most part, that's what you encountered and dealt with in statics. But if we want to determine what effect these loads have on this object, then we need to consider and look at what we call internal loads. And this is very much like method of sections. I know everybody was supposed to do method of sections when you did trusses, right? This is going to be the exact same procedure, but we're going to do it not to a truss. But the truss is a good example of the difference between internal and external. In fact, that's one of the few places in statics where you actually did find internal loads. You had a truss, and you figuratively cut it in half and use method of sections to find a force in actual truss members. Those were internal loads, right? All the applied forces and your support reactions acting on the truss were external loads. Right, but we're going to do the same thing with any type of structure. So say we have, we'll use a different color. Say here at this point, call it C. What we're going to do is figuratively cut this structure into half. And if we draw a free body diagram of either half, the loads that are acting on that cross section are the internal loads. And so you could do either side. Obviously, if I was solving this problem, it's actually less work to do the right side. But just for illustrative purposes, let's say we're looking at the left side. So we would include any of those support reactions that are acting on the left side. Now, if we're including the weight, as I said, most of the time weight is neglected. But if you wanted to include the weight, you would only include the weight of everything to the left of C, which would force you to, let me move point A over here. The weight is actually a distributed load. Right, so you would have, again, whatever the weight per length is, and you should know from statics, you can replace the distributed load with an equivalent force. Right? And so you would replace that let's call it weight left. So whatever that distributed load for the weight acting on the left side of this member, you would include that as a distributed load, replace it with an equivalent force. Obviously, it's would go halfway. But the main thing here is what happens at C. We have And I'm using the notation the book uses. The axial force he denotes with N for normal. The shear force he denotes with V. And the bending moment he denotes with the M, and then subscript C to indicate those are the axial force, the shear force, and the bending moment acting on the cross section at C. Now, right now, we're not going to be encountering any twisting moments or torsion. So all we're going to see right now are axial, shear force, and then a bending moment. But you could also, if you looked at the free body diagram of the right side, again, have any applied loads. This is why I said that if I was solving this one, I would work with the right side because it's less work. Right? But we have the same internal loads acting on that cross section at C. We have an axial force. We have a shear force. And we have a bending moment. Now, a couple things to point out here, because we were getting close to out of time, and this is, we're going to stop right here, but what I've denoted here, this NC, VC, and MC, those are the internal loads. And my blue pen's dying on me. Acting at C. And that's what this section is really all about, is determining or calculating what the internal loads are acting on a particular cross-section. Because those internal loads that act on that cross-section, that's going to determine how much this member is going to stretch, how much is it going to bend, is it going to break or not. Those are the forces and moments that we need to be able to determine. Now, one last thing, note that these are the same magnitude, but they're opposite direction. So if you look at the internal loads on that cross section, they're exactly the same as the internal loads on the free body diagram of the right side. They're just in the opposite direction. Right? All right, so that's what we're gonna start with on. Let's see. All right, I'll start say on Wednesday, but we meet every day, so that's where we'll pick up. Tomorrow is we'll actually go through and work one of these. Take some member that's got some external forces acting on it, cut it, and determine what the internal loads are acting on a particular cross section. Right? That's what you're hopefully going to get out of this first section, section 1.2. All right, but we're getting close out of time, and it's a good place to stop. So I'll ask again, anybody have any questions before we end our first live session? Thank you. Have a good day to you too. I will mention one thing. Typically, most days, if you have, some specific questions or problems that you want to stay online after the official session ends and I stop the recording, if you got, a couple of questions you want to ask me about, well, it would be, easy to do maybe while we're in this WebEx session. I will stick around for a little bit after I stop recording, and we'll be happy to answer, questions at that point. And obviously, if nobody has any questions, then I'll end the session. But any questions today? All right, so I'll check on why the suggested problems list is not available in Canvas, and I will attempt to see if I can get this recorded session uploaded, and that link hopefully should be available in Canvas sometime later this afternoon. Otherwise, I'm going to end the session, and I will see, or I won't see you. You won't see me, but you'll hear me tomorrow at 11 o'clock, and we'll continue where we left off. All right? All right. So everybody have a good day, and we'll continue tomorrow at 11.